The energy usage and costs of AI is just getting ridiculous. So let's dive into how they interact with energy policy and renewable energy to get your answers that you need about how to cook cheese on toast. So, data centers and renewables. Data centers are like giant, massive warehouses full of computers, servers that are doing lots of data retrieval tasks or computational tasks. So they're either running loads of hard drives or they're running loads of processors or graphics cards. And these centers are massive and they take a lot of energy, and it's been widely reported that a lot of these data centers are now one of the major loads of any country. They're owned and run by tech companies. You've got these few large companies that are owning basically all the infrastructure, cloud computing and data centers. So it's likes of Amazon, Microsoft and Google. If you want to run a virtual machine, if you want to do like web-based computing, if you want to host software, if you want to host websites, all of that is done basically with one of those three big providers and their data centers. Now, all that is highly energy intensive, but these companies are the same companies that started in the dot-com bubble in the early 2000s, the original tech sector, and they're priding themselves on being cool companies and being ahead of the curve, being good places to work and really having a good ethos. Now, semi-recently, some of those ethoses have come under fire for being maybe not as good as they were, but as an example, they've always leaned into having renewable energy or being involved in renewable energy, and Google has made a lot of song and dance about the fact that it uses renewable energy, and so has Amazon. And essentially what they tend to do is they're looking at ways that they could either power their data centers with maybe solar panels on the roofs or buy renewable power for the data centers. And they've been able to do that, especially in Western countries in the last decade, because there's been lots of products that have enabled them to say that the electricity that they use is green, the same way that you have your energy bill at your house maybe says that you're using renewable energy. They have similar products for large companies, and because they're large companies, they're more directly responsible for the energy contracts and paying the different parts of the energy bill, like the grid fee and the generation costs. So they actually have access to these deals where they're doing a direct deal maybe with the generator instead of through a supplier like the average person or a small company would do. So these companies do have a lot of power in these sorts of transactions, and they actually represent large customers for things like wind farms and solar farms. So a wind farm could potentially sell all of its output to Amazon through a power purchase agreement, and that says that whatever we produce, you get to use. Now, someone is responsible as a third party in the middle, and that's normally the equivalent of what we have as a supplier. They're just responsible for a much smaller amount, and what they do is called sleeving, which is where they take what's left over or what's not used or what's needed extra on either side, the supply or demand side, and get it from somewhere else. So the key point is that in all these contracts, although they may have purchased all the energy output from one of these power plants, that doesn't cover all their energy needs, and they have to get some of it from somewhere else. And that requires there to be a grid in place, because if you're running a highly reliable and redundant server farm, you need to have ability to keep the lights on. Running computers like this is very energy intensive, and they've done stuff like experiments to run servers under lakes or in the sea, like have underwater computers so that their cooling bills are lower, and cooling is a large part of the energy usage of data centers. So these companies have got a lot of cash because of the nature of their business. They have often been using this cash to try to invest in the future and invest in ways to save energy, but also in terms of those buying whole outputs of power plants, invest in public relations, which is to say that they don't have to sign a PPA with a wind farm or a solar farm, and it's probably not that much cheaper than, might even be more expensive than buying from the open market when you tot up all the rest of the costs that they have to pay on top of that. It's just more the fact that if Google says that they're 100% renewable, they know that they can steal a certain amount of customers from Amazon if basically all you're using is the commodified use of cloud computing. And this corporate vanity is and was one of the big drivers of the energy transition. Corporations know that if they're selling something that you could essentially get somewhere else, that one of the main things that they have to offer is customer satisfaction or people wanting to use their services, and that can come through saying that they have 100% renewable credentials. And that can be achieved through these contracts called power purchase agreements, which associate the output of a wind farm with the usage of a data center, for example. And in turn, these kinds of contracts were some of the only financing options available to large wind farms after government subsidies had run out. So they still happen. Corporate PPAs are a large slice of the funding that is available for wind farms these days. So a corporate PPA is a corporate power purchase agreement. That is a power purchase agreement between a corporation and a power plant, in most cases wind or solar farms. AI. So we're in AI now, and what that means is that the energy draw from these data centers has gone away from running like hard drives and storage, which can be optimized in a variety of ways, and towards computing and inference, which is like running CPUs and GPUs. And that means that the power profile has probably changed quite a lot. But even when it was just looking up photos on hard drives or looking up old files or whatever that you had stored on the cloud, if you actually are responsible for paying a bill at a company for cloud computing, you know that every single query to a database actually costs you money. And if you pay for the speed at which you want the returned information to come back to you. So if you've got lots of data that you want to be stored, but it doesn't need to be that secure, and you don't mind if it takes you a few seconds every time you ask for a piece of data for it to get given to you, then you can pay a fraction of a penny for the ability to retrieve data. But if you want it every time, highly resilient and really fast, then you might have to pay maybe a penny every gigabyte or every megabyte of data. I don't know what the rates are, but it really does scale. So it's just to illustrate that using cloud resources, they really do charge you for every single operation that the computer does, and that can be the equivalent of just looking up a file on a database, the same way that you might just use your computer normally. So it's really, they really start to track when they run these big data centers, the actual energy used to go and track down a piece of information and bring it out, kind of like the Matrix, that sort of thing, to actually what they charge the customer. They've built these giant models, which took an unbelievable amount of computing power to build these models. The models are essentially a big database of weights, which are weights of functions. And then when you ask it something, it basically sends your request through a massive function, which is like loads of if this then that type functions, all tied together in a complexity that's probably so complex that you can't even imagine how complex it is. But it means that it actually takes a lot of energy to query something. So back in the day, in the earliest sort of days of statistical learning, which is like 10 years ago, there was lots of papers written about how it was possible to train statistical models to do stuff like wind power forecasting in very sort of advanced techniques, and to get good skill out of these models. But it would actually cost us the amount of equivalent energy to that of a regular car in its entire life cycle. So just to build one model on a desktop computer might take a few weeks or something. So that is equivalent energy usage of maybe using a car for its entire life. So it was just to highlight the fact that we were making advances in maths and statistical methods, but these come at the cost of using a large amounts of energy. So now it's kind of the other way around, where you do loads of work and have to buy loads of stuff to be able to build models, and then when you've got the models, they get used loads of times, and when you use the model, it also uses energy, and that actually uses more energy than building the model. And I believe that OpenAI's finances have recently come under scrutiny, and their costs of inference is actually very large compared to the costs of building the model. And that means that thousands and thousands of people, maybe millions, every day are querying these models, and querying it, just like looking something up at the database, costs money because it takes energy to run a bunch of bits through this matrix to get it out again, to get your answers that you need about how to cook cheese on toast And there used to be lots of research into stuff like transfer learning, which is like, how do we take a model that we've already built and transfer it into something else? Because ever since the start of statistics, computation intensity has been a problem when trying to solve complex problems, and it's ever much more of a problem right now. So how are they trying to fix it? Well, there's lots of ways that they do it. If you're building a giant data center in some land that you've bought, you can't just say we need loads of energy, because the grid operator is probably planning grid usage, electricity usage many years in advance, and so you might have to wait years to get connected. But in most countries around the world, especially here, there's different rules for what's called private wire. So private wire is where you have your own power plant on site, and essentially you're running power from the power plant to your use case. It could be a factory, it could be a data center, and there's different rules. You can build quickly. It's cheaper because you don't pay grid fees, but there is like a size limit on the kinds of power plants you can build. But in different countries like the US, they're actually building separate power stations to power these data centers, and that's been under fire in the news because of the non-environmentally friendly credentials. So a lot of these data centers are using gas, because gas power stations are very efficient power stations, a lot of them, and they're also the most appropriate type in today's world, because you can build them behind the meter private wire, so they're not connected to the grid, but they're highly controllable in their output, because natural gas is a highly storable form of energy. So that means that as the data center's power usage goes up and down, they can easily match that with the power station. And no matter how you connect the power station to the power usage, if it's a factory or whatever, the controllability of the power station's output is important, because even if it's a DC grid, they still need to match supply and demand to a very sort of strict regime. So private wire, good. Corporate vanity, good. But private wire power stations, like gas power stations, might use lots of water in the local area. They might also pollute the air in the local area. So actually, these data centers, while they're trying to maintain their green credentials, they kind of realize that everyone's kind of softening on the climate, and everyone's more leaning into like AI or other things like that, or like world wars. So all these companies sort of think they can sort of get away with having a gas-powered power station, and maybe they can, but it's not necessarily great for the environment. So about 10 years ago, again till about 5 years ago, there's lots of research into ways that data centers could use renewable power outputs. And as I said before, the main point about the issue is that you need to have controllable power output, what we call dispatchable or firm power. So you need to know how much power you're going to have, and you need to be able to control the output. So you could run batteries, wind and solar all together and have like a virtual clean power plant, but actually the utility and cost might not match a gas power plant. And when it's all private and behind the meter private wire, there's not a lot of control that the government can do in terms of financial incentives. If it's cheaper, they're probably going to do it. And so this is a bit of a problem when you're trying to regulate these sorts of things, because you may need these data centers for your economy, but these data centers need energy. You can't deliver the power plants fast enough. You kind of have to let them do whatever they want to do. I know Tesla's basically building a giant power data center in the US, and they're building lots of gas turbines to power it. And it is what it is. It's kind of a move back towards the old industrial revolution style of building a mill or a power plant next to your factory. Whether it's creating demand that's useful or not is yet to be seen.